Milky Way galaxy with the Andromeda galaxy and possibly the Big Rip.
How would the sun die?
Oh, the sun, like any star, it will run out of fuel in its core and it starts changing. It starts bloating and getting so large that it will engulf the orbit of Mercury and Venus and come very close to Earth.
In the vast cosmic tapestry, where stars twinkle like diamonds in the night, incredible celestial spectacles unfold. Picture events of mind-boggling magnitude, eclipsing galaxies and sending ripples across the cosmos. Today, join us on an exploration of one such cosmic drama, the dazzling phenomenon called a supernova. From ancient times, when civilizations viewed these occurrences as cosmic omens, to the present-day astronomers unraveling the universe's mysteries, supernovae have captivated our curiosity. Enter the scene stealer, Betelgeuse, a star dimming dramatically, sparking speculation among scientists about an imminent supernova. If it happens, this stellar explosion could be Earth's brightest spectacle in over 4 centuries. Embark on a cosmic journey as we delve into the enthralling realm of supernovae. In the grand cosmic theater, stars take center stage. They are born, live their celestial lives, and ultimately bow out in a spectacular performance. Some stars, however, conclude their cosmic journey with such flair that they outshine entire galaxies. These are the supernovae, the grand finales of stellar existence. But what exactly is a supernova? Imagine a powerful, radiant fireworks display in space. In simple terms, a supernova is a stellar explosion that occurs in a star's twilight moments. When a star's core can no longer sustain the outer layers through nuclear fusion, gravity takes over, causing the core to collapse and culminating in a spectacular explosion that momentarily outshines entire galaxies. So fasten your seatbelts as we navigate the cosmos, unraveling the captivating tales of stellar cataclysms and their impact on our little blue planet. Join us in understanding our place in the vast cosmic drama, a story told by the stars themselves. The burst of energy unleashed by a supernova is incredibly vast, equivalent to the total energy our sun emits throughout its entire 10 billion-year lifespan. Supernovae aren't just captivating celestial occurrences. They play a pivotal role in shaping the cosmos. These cosmic explosions are responsible for dispersing essential elements across space, elements crucial for the creation of planets and life as we know it. Interestingly, it is believed that most elements heavier than iron, such as gold and platinum, owe their existence to the explosions of supernovae. Therefore, the gold in your jewelry, the iron in your blood, and the calcium in your bones all originated from stars that met a spectacular end through explosion. Centuries before the invention of telescopes, space probes, and modern astronomy, ancient civilizations were avid skywatchers. They identified patterns, charted constellations, and documented celestial occurrences. Among these events were the sudden appearances of new stars, which we now recognize as supernovae. One of the earliest recorded instances of a supernova dates back to 185 AD, when Chinese astronomers noted a guest star that illuminated the sky, visible even in daylight for several weeks before fading away after about 8 months. Today, we identify this as a supernova, and its remnants, known as RCW-86, have been observed using contemporary telescopes. Another historically significant supernova is SN 1054, which led to the formation of the Crab Nebula. Discovered by Chinese and Arab astronomers in 1054, this guest star shone about 4 times brighter than Venus and remained visible during the day for 23 days. The remnants of this ancient supernova now constitute the mesmerizing Crab Nebula. The way ancient civilizations perceived the cosmos underwent a significant transformation due to their observations of supernovae. These celestial events challenged the prevailing notion of a static universe, which was deeply ingrained in various cultures. Furthermore, these cosmic occurrences were not only used for astrological predictions, but were also regarded as omens. In our modern era, the study of supernovae has evolved beyond considering them as omens. Instead, we view them as invaluable opportunities to deepen our understanding of stellar life cycles, the formation of elements, and the overall history of the universe. Despite our enhanced cosmic knowledge, the allure of these powerful and mysterious stellar explosions continues to captivate us. A recent focus in astronomical circles has been the star Betelgeuse in the Orion constellation. This red supergiant, approaching the end of its life, caught astronomers' attention when it underwent a dramatic dimming phase in late 2019. Speculation arose about the possibility of it transforming into a supernova. However, the star has since returned to its usual brightness. The prevailing explanation attributes this event to Betelgeuse emitting a substantial dust cloud, temporarily obscuring its light and causing the dimming effect from Earth's perspective. As the dust dispersed, Betelgeuse's brightness reverted to normal. This episode serves as a reminder that the universe is dynamic, showcasing the birth, life, and spectacular demise of stars. Every twinkling star in the night sky narrates a tale that predates the moment its light reaches us. The life cycle of a star unfolds as a transformative journey, commencing as a vast cloud of gas and dust known as a nebula. Within these celestial nurseries, clusters of gas and dust start to collapse under their own gravitational pull. As this collapse occurs, the materials heat up and come together to form a protostar. Over the course of millions of years, this protostar continues to accumulate mass from the surrounding nebula. As it grows, the pressure and temperatures at its core steadily rise. Once the core temperature reaches around 27 million degrees Fahrenheit, nuclear fusion ignites. The protostar transforms into a main sequence star, much like our Sun. These stars can exist on the main sequence, burning hydrogen in their cores for billions of years. However, inevitably, the hydrogen fuel supply is depleted. What unfolds next hinges on the star's mass. In stars comparable in size to our Sun, the core contracts and heats up, causing the outer layers to expand. This transformation turns the star into a red giant. Eventually, the core collapses and the outer layers are expelled, creating a planetary nebula. This process leaves behind a white dwarf. Yet, as we journey through space, we discover that not all stars conclude their life cycle in the same manner. Some stars undergo a spectacular event known as a supernova. The type of supernova is primarily determined by the mass composition of the original star, each with its distinct characteristics. For instance, spectral analysis of type I supernovae reveals a lack of hydrogen lines. The most renowned subtype, type Ia, occurs in a binary stellar system. In this scenario, a white dwarf, the condensed remnant of a star akin to our Sun, draws in matter from its companion star. Once the white dwarf reaches a critical mass, it undergoes a thermonuclear explosion, resulting in a supernova. On the flip side, type Ib and Ic supernovae are believed to occur when the cores of massive stars, which have shed their outer layers of hydrogen, collapse. Type II supernovae, on the other hand, involve helium. Now, let's delve into one of the most commonly observed supernovae, type II. These cosmic events stem from massive stars much larger than our Sun, with a minimum mass of 8 times that of the Sun, undergoing a dramatic transformation. Throughout their existence, these hefty stars engage in a constant tug-of-war between gravity pulling inward and the outward force of fusion. When a star depletes its nuclear fuel, gravity emerges victorious. The star's core collapses rapidly under its immense gravitational pull, leading to a spectacular explosion known as a supernova. The outer layers of the star burst forth in a breathtaking display, temporarily outshining the entire galaxy. The remnants of the star may give rise to a dense neutron star or, in the case of significant mass, a black hole. However, the star's impact persists. The explosion scatters the elements forged during the star's life into space, sowing the cosmos with the building blocks for new stars, planets, and potentially even life. When a star undergoes a supernova, it's not merely a dazzling light show, it stands as one of the most energetic events in the universe. The colossal energy released in a supernova explosion is so immense that it equals the energy the Sun would emit over its entire 10 billion year lifespan. But what happens to all the energy generated in a supernova? The majority of it is carried away by neutrinos, tiny particles with almost no mass that are produced in large quantities during a supernova. These particles travel incredibly fast, nearly at the speed of light, taking approximately 99% of the explosion's energy with them. The remaining energy is released in the form of light and other types of electromagnetic radiation. This includes gamma rays, which are the most energetic form of light, and X-rays, less energetic but still much more powerful than the light visible to us. The visible light produced by a supernova is so intense that it can momentarily obscure an entire galaxy. This brightness makes supernovae crucial celestial landmarks for astronomers, as their light can be observed from great distances. While observing supernovae is fascinating, they also present potential dangers. The massive energy and radiation released during a supernova explosion can have significant consequences, particularly if the supernova is in close proximity to Earth. One major concern is the impact on our planet's ozone layer, acting as Earth's sunscreen against the Sun's harmful ultraviolet radiation. An intense gamma ray burst from a nearby supernova could potentially destroy the ozone layer, increasing the amount of UV radiation reaching the Earth's surface. The heightened UV radiation can have adverse effects on Earth's biosphere, leading to increased rates of skin cancer in humans and other animals, as well as disrupting photosynthesis in plants, potentially impacting the entire ecosystem. In addition to gamma rays, a supernova also emits a stream of high-energy cosmic rays. These particles can further damage the ozone layer and generate secondary particles in the Earth's atmosphere, increasing the overall radiation dose. As we explore the dangers associated with supernovae, there's another intriguing aspect to consider: gravitational waves. These are ripples in the fabric of space-time caused by some of the most violent and energetic processes in the universe. In 1916, Albert Einstein made a groundbreaking prediction about gravitational waves in his general theory of relativity. According to Einstein's calculations, when massive objects like neutron stars or black holes orbit each other, their acceleration causes a collapse of space-time, creating distorted space waves. The leading candidates for generating such waves are supernovae, known for their immense mass and explosive energy. When a massive star collapses and explodes, the resulting asymmetry in the explosion could potentially generate gravitational waves that ripple through space. By the time these waves reach us, they are incredibly weak and pose no threat to Earth. However, they provide a unique opportunity to explore and study the universe in a new way. Scientists have already started detecting these waves using highly sensitive instruments, marking the beginning of a new era in gravitational wave astronomy. Fortunately, the likelihood of a supernova occurring close enough to impact Earth is quite low. Nevertheless, it is essential to understand these potential dangers, serving as a reminder of our connection to the cosmos and how events light years away can influence our home planet. As we've seen, supernova explosions are powerful events with far-reaching consequences. But did you ever imagine that supernovae might have shaped Earth's history? Scientists have uncovered evidence of past supernovae in the form of iron-60, a radioactive isotope found in ancient geological layers and Antarctic ice cores. Since iron-60 is not naturally produced on Earth, but originates from supernovae, it suggests that remnants of these stellar explosions once scattered across our planet. One notable event is the Pleiades supernova, which occurred approximately 2.7 million years ago. Some scientists suggest that the explosion of a distant star, known as a supernova, might have influenced Earth's climate during the Ice Age, potentially contributing to a cooling period. There's also a theory connecting supernovae to mass extinctions, proposing that cosmic rays from a nearby supernova could harm the ozone layer. This damage could lead to increased ultraviolet radiation on Earth, negatively impacting life, especially shallow oceanic organisms. While these ideas are still under investigation and subject to debate, they underscore the potential influence of cosmic events on our home planet. It serves as a reminder that we are part of a dynamic and interconnected universe. When we gaze into space, we're not just looking into the past, but also contemplating the future. Stars continue to be born, live, and eventually die, with some concluding their life cycle as supernovae. What lies ahead for supernovae in our Milky Way galaxy? Astronomers estimate that, on average, a supernova explosion occurs in the Milky Way about once every 50 years. However, most of these events aren't visible from Earth due to obstructing dust and gas. The last supernova visible to the naked eye in our galaxy was observed over 400 years ago by the renowned astronomer Johannes Kepler. But fear not. Astronomers are closely monitoring potential supernova candidates. These include stars like Betelgeuse in the constellation Orion and Eta Carinae in Carina. Both massive stars exhibit peculiar behavior, leading astronomers to speculate about their potential to become supernovae in the relatively near future on an astronomical timescale. A recent study has provided new insights into the enigmatic behavior of the celestial giant Betelgeuse. This star, known for its semi-regular variations, has been the focus of intense scientific scrutiny. In the case of Betelgeuse, these changes manifest in alterations in brightness or light intensity. Unlike a strict cycle of increasing and decreasing brightness, the star oscillates predictably but not entirely regularly. Scientists have pinpointed 4 distinct periods in Betelgeuse's variations: every 200, 420, 230, and 185 days. They propose that these intervals align with the star's pulsation patterns, specifically the radial principal mode and the first, second, and third overtones. This analysis, considering the intricate interplay between pulsation and convection, suggests that Betelgeuse is in the later stage of core carbon combustion. The study delves into the notable event known as the Great Dimming, which caused Betelgeuse to noticeably dim from December 2019 to February 2020. Researchers speculate that during this time, Betelgeuse's effective temperature dropped by approximately 100 K, potentially leading to significant mass ejection. This occurrence sparked a flurry of observations and analyses aiming to unravel the mysteries of this distant star. The exciting revelation from the study suggests that Betelgeuse could be the next star in our galaxy to experience a supernova. Given its current late carbon burning stage in the core, its intense brightness and intricate variations, Betelgeuse stands out as a prime candidate for this captivating cosmic event. The research also highlights discussions on the star's high rotation rate as a red supergiant, prompting considerations about its evolution, including the possibility of past mergers with another star as a source of angular momentum. It's crucial to note, however, that predicting the exact timing of a star going supernova is exceptionally challenging due to numerous factors not fully understood. Even if a star exhibits signs of an impending supernova, it could be thousands or even millions of years before the event occurs. Rest assured, when it finally happens, it will be a breathtaking spectacle. Exploring supernovae plays a pivotal role in unraveling the mysteries of the universe. These cosmic explosions mark not only the culmination, but also the genesis of celestial phenomena, enriching the cosmos with essential ingredients for the birth of fresh stars, planets, and perhaps even life. As we journey through space, we're consistently confronted with the awe-inspiring and enigmatic nature of the universe. Supernovae stand as a testament to the life cycle of stars, the formation of elements, and the interconnected nature of the cosmos. Delving into their various types, understanding the risks they pose, examining their impact on our history, and contemplating the future are all part of our exploration. While these celestial events are undeniably destructive, they also hold the power of creation. They sow the seeds for the emergence of new stars, planets, and the potential for life to flourish. The study of supernovae extends beyond comprehending their breathtaking occurrences. It's also about grasping our position in the vast cosmic tapestry. They serve as a reminder that we are crafted from the same stellar materials, intricately connected to this expansive, dynamic, and ever-evolving cosmos.